这群人在领跑创新，技术边界被突破，行业标准被刷新，推动世界向前，新建美好未来。爱旭为零碳世界重新定义光伏。
爱旭启用的这个组件发电量大，效率高，尤其是现在高温季节，每天的发电量可以解决我们50%的需求。爱旭给我们的提供服务，从前期的方案、中途的施工，包括现在的运营，都体现得非常专业。我们会继续使用爱旭的产品跟服务，共同打造一个零碳社会。
Distinguished officials and dear guests and all the audience watching us globally online, ladies and gentlemen, good afternoon. I myself is the moderator today, Xu Nuo. I'm very happy to be here with all of you. At this very beautiful day of the winter of Beijing covered by snows, we're all gathered here in the beautiful city of the capital and having this ABC Bi-Facial Module launch ceremony with the theme of Innovation Beyond Imagination. Here, on behalf of AIKO, I'd like to extend the warm welcome and heartfelt thanks for all the officials and guests to come afar. Welcome. And now please allow me to give you the introduction of the guest present here today. They are the Secretary General of China Photovoltaic Industry Association, Wang Shijiang. The China Energy Research Society expert Li Youzhan, welcome. The Director of the PV Commission of the China Renewable Energy Society, Zhao Ying, welcome. The Director of the Yangtze Institute for Solar Technology, Mr. Shen Hui, welcome. The Global Head of Solar Business and R&D Technology Competence Center of TUV Rheinite, Dr. Christomas Monokropoulos. Chief Design Engineer, China Energy Engineering Group, Guangdong Electric Power Design Institute, Zhang Zhengchuan, welcome. The Head of PV Technology Department of Huanan Clean Energy Research Institute, Zhao Dongming, welcome. The Director of the Institute of Smart Energy of Guohe, Wang Jing, welcome. The Shandong New Energy Development Co. Limited of China Energy Party Secretary and Executive Director Cui Ming, welcome. The Chief Designer of CHEC, Cong Jian'ou, welcome. General Manager of Anhui Kuaiyi PV Technology, Power Generation Company, Sheng Yansheng, welcome. The General Manager of Shanxi Jinse Nianhua New Energy Company, Bai Zongyu, welcome. The Chairman of AIKO Group, of AIKO Group, Mr. Chen Gang, welcome. Senior Vice General Manager of AIKO, Xu Xinfeng, welcome. And the Vice General Manager of AIKO, Xia Hengliang, welcome. Let's also welcome CTO of Solar Lab, AIKO Europe, and the inventor of TOPCon, Dr. Frank Feldman. The Deputy General Manager of the Product Technology Department of AIKO, Sheng Jian, welcome. We'd like to welcome all the officials and guests present here today. When we are accelerating the global consensus for the double carbon target, now we are making the effort to accelerate into the goal of the zero carbon energy, which is a new era in the future. AIKO is a global leading new energy science and technology company. We're always remain committed to make the continuous groundbreaking innovation to promote the leap forward development of the industry. Ladies and gentlemen, let's give a warm applause to welcome the chairman of AIKO, Mr. Chen Gang, to give the opening remarks, redefining PV. Welcome.
Dear guests, dear leaders, friends, good afternoon. It's a great pleasure to meet everybody here in this very busy day and to invite you to come to our product launch. First of all, I do wish you all a very good Merry Christmas and Happy New Year. And I also wish everybody great success in the coming year of 2024. Thank you. So today for AIKO, starting from 2021, when we push forward the new products, it has already been 2 years. And today we are having the product launch of our utility products. So we are very glad to say that finally we are able to put the back contact technology to cover residential, CNI, and utility, these 3 different scenarios. So I would like to say that in the past several years, the scientists in AIKO and also the R&D people in AIKO, our engineers and our staff from all different parts of the world, our suppliers for materials, for equipment, the supporters of AIKO, the universities that we are collaborating with, including Professor Shen, who's coming here today. I do thank you all for your support in the past several years so that we are able to open a new era for the industry and to build a new ecology and also to build a brand new type of product series. That is our ABC brand product series. Me, I'm really happy. My feelings are complicated in my entire life. Finally, I'm able to promote a new product series and to build a complete product ecology. And up until today, in this afternoon, that I'll be able to give the presentation here. So in 1887, we see that Hertz founded the photoelectric effect, and he found that the light can be transferred into electricity. In 1905, Einstein founded the photoelectric effect equation, and in 1954, the Bell's Lab promoted the first crystalline PV solar cell with the conversion efficiency of 6%. In 1961, the Shockley Semiconductor Lab finally that they're able to have an estimate of the theoretical efficiency of solar cell to 30%, and this figure in 2013 has been corrected to 29.43%, and the figure finally in the year of 2018 was corrected by Harmony Solar Lab Institute to 29.56%, and that is the theoretical limit of crystalline silicon PV cells. So I think that starting from Shockley in 1961 till today, 60 years has already passed, and in the past 60 years, from theory to practice, from the past to today, for AIKO, we are always able to be glad to witness this, to practice it, and to prove it that we are able to make it happen, to reach the theoretical limit. And that is what we are bringing, that is the ABC cell technical route. So in 2016, AIKO has developed the tubular PERC technology, and that is the low-cost bifacial PERC cell that we have promoted, pushing PV industry into PERC era. So before 2016, we know that we have the polycrystalline silicon technical route. At that time, we have seen the rising of a lot of different technical routes, the mono PERC technical route, etc. At that time, in the P-type era, we are considering that what is the final technical route that we'll be following, and we think that at that time it should be PERC and it should be bifacial PERC, and it should have a lower cost compared with polycrystalline silicon. And I think in the future that there will be no polysilicon, and what we want is to have a solar cell with higher efficiency. In 2019, AIKO has developed the first 2010 big size cell and delving the last benefits of PERC technology. So at that time, we were considering that once we have the bifacial PERC available, then basically it's already a dead end, and the theoretical limit of PERC is about 24.5%. And until today, in the production lines, our PERC cells can already reach an efficiency of about 23.6%. That is very close to the theoretical limit. So at that time, N-type is not very mature, so what else can we dig? So what we found is that we can put the 12-inch semiconductor technology into the application of solar cells so that we can have a bigger cell available and then further reduce our cost by 10%, and that is what we call the big size era. But when we say that the P-type benefits is already approaching an end, what should we do? Then the next stage is definitely the N-type era. So when we talk about the N-type era, what we need to do is, do we want to have a technology with a lower efficiency, or we want to directly go to the best? So the best is of course to approach to the ultimate conversion efficiency, and that is 20% something. And can we make it happen in mass production? Are we able to make it happen? That is point number one. Second is, do we really need to achieve it? So you all know that China has already had the dual carbon policy, that by 2030 we need to have carbon peaking, and also by 2060 we need to have the carbon neutrality. So we need to do our best to develop the ultimate technology that is known to us, so that we can support the country to make it happen, to achieve the dual carbon goals and to make our contributions. And that is why we've decided that no matter how difficult it is going to be, we need to approach to the final end to achieve the ultimate conversion efficiency. And that's finally, after years of efforts, and we've got it happen, and that is the N-type technology that we are presenting. So the N-type ABC technology, first of all, we wanted to approach to the theoretical limit. First of all, for the model, can it achieve the theoretical limit? If the model can achieve it, how can we make it happen in the mass production? And when the mass production rate is closer to the theoretical limit, what will we do next? So we know now our mass production conversion efficiency is about 23.5%, and is very close to the 24.6% in terms of the model simulation. So in the past several years, we have done a lot of efforts, and now I would like to give you guys several details for the N-type ABC technical road. We think that this can actually achieve the theoretical limit and how we make it happen. Let's take a look. First of all, in terms of the silicon wafer technology, currently the traditional technology is the RCZ method, and its problem is that it's low in resistance and high in oxygen. The problem is that it's having a lot of impurities, and it's difficult to prepare for the high efficient crystalline silicon cells. If the wafer is not good enough, then it's difficult for us to make a high-efficient solar cell, of course. So that's why we're having a new technology that is the LDMCZ method. In this, we are controlling the resistance and also controlling the broken lines. You'll see that what we have developed is actually how we are making breakthrough in terms of the material, and we can achieve a breakthrough of more than 27% in terms of the conversion efficiency for the cell, and that is laying a very good foundation for the later on module manufacturing. So this is what we have done after years of effort, and this is the so-called a low oxygen, high resistance silicon wafer that we're talking about. On top of this, we are able to build better cell technology and module technology, of course. So moving on to the cell technology. So for BC is back contact. The traditional method is that we are using the photomasking method that includes gluing, corrosion, cleaning, etc., many different processes. This has really high cost, low yield rate, and low capacity. So for us, when we are building a solar cell factory, then we are making about 3 million solar cells per day. So to make it happen, to make solar cells very quickly, we are using a new technology that is the ultra-fast laser printing technology, that we are getting all the process done in a very quick time period, and this will give us low cost and high capacity and also high yield rate. Now our factory in Zhuhai in Yiwu is actually benefiting from this ultra-fast laser technology. So this is the reason why that we are able to put BC technology into a low cost. And personally speaking, I think in the future, our cost on this perspective is definitely lower than that of PERC. If this technology cannot have the breakthrough, then it will be difficult for us to control the cost, of course, and to have a rather competitive cost. So moving forward, silver paste. So on the left-hand side, you'll see that is the traditional method that is using the silver paste in the production of the solar cells. And we know that the consumption of silver in the manufacturing of solar cells is already about 15% of the entire consumption of that across the globe. And this figure will grow to about 80 to 90% in 2050. Especially for the back contact technology, the usage of silver is much more than that of the usage in other different technical roads. If we cannot have any breakthrough in terms of the usage of silver, then it's difficult for us to have any breakthroughs. When the usage of silver takes about 90% of the overall cost for the production of solar cells, then that means that we're actually at a bottleneck. So that's why we've been always talking about non-silver technology, and that is what we AIKO is using. So we're using other different metals, and we are the first of our kind, the first company across the globe that we are not using silver in the manufacturing of solar cells. And also our entire cost can reach to the overall requirement, and our yield rate, as you know, that is already more than 95%. So this entire process, without using silver, it's actually bringing us a lot of benefits, and also we are making a lot of progress and breakthroughs. And so that's all for the cell technology. If we have a good cell and we cannot package it very well, then it is also a problem. So that's why we also have new technologies in module. And we've got two brand new technology. First of all is the high reliable 0BB serial welding technology. We've seen a lot of reports that a lot of companies are actually doing the broadcasting that they're also using the 0BB welding technology. But for this technology, there is a huge issue that is the reliability. How to make sure that we are having enough dragging length. If this dragging length is not enough, then basically we'll have figure problems. So through our concerted efforts, we've actually achieved this high quality in terms of welding. Our welding, compared to the current PERC and TOPCon, we're having a stronger tension and we're having a better quality, a better effect. And also, via the breakthrough in 0BB technology, we can improve the encapsulation loss by 1.5%. So moving on, other breakthroughs that we have, that is the bifacial efficiency, and that is what we are having the launch today, the 70% bifacial high efficiency module. Before, a lot of media, a lot of press, a lot of friends in the media, and a lot of technical paper has reported that for BC technology, although it is very good, it's aesthetic, but it does not apply to the bifacial modules, because we are putting all the cables on the back end of the cell, then we are losing a lot of the efficiency on the back end. So that's why we are considering on this. So we are growing from the previous 30 to 40% of efficiency to nowadays the 70% of conversion efficiency with the combination of the front end and the rear end. So even though in the utility scenario that our comprehensive power output is much more than other technical routes, when we are talking about the both side power output. So just imagine that, because the cables that we have, when we are putting all the cables on the back end, then the cable are more dense on the rear side, but still we're able to have a higher efficiency. That's a very big difficulty that we have managed to break through. So with having the breakthrough in cell and module, moving on, what we have done on quality. So in terms of quality, for the N-type, in terms of reliability, by nature that it is less reliable than P-type. But how to grow the quality and how to maintain our power output, that is a consideration that we need to make, because we want our products to last for 30 years and more. And what we have promised is that we will guarantee our power output by 30 years, and the first year degradation is less than 1%, the year-by-year degradation is less than 0.35% per year. That is the promise that we from AIKO that we're giving to the N-type era, and our guarantee and promise to this new era. Because as I mentioned that by nature the N-type is definitely less reliable than P-type, so that's why we need to solve this, and that's why we need to have a lot of innovations and breakthroughs. And so today we're really happy to provide our clients with the 30-year guarantee, power output guarantee. So we hope that with our concerted efforts moving forward, maybe we can increase this entire time period of guarantee to 35 years or 40 years, so that we can actually having all the parties related to actually benefiting from this process. So all the people in the PV industry, after 60 years of efforts, we have proven that for the past theories, either from Shockley to Bell to Hamley, that their theoretical limit is actually scientific, that we can actually make it happen. But what happens next? What is the next stage technology? Hereby, AIKO, we are also doing a lot of studying. We think that maybe in 5 years' time, in 8 years' time, what will the industry be? We see a lot of technical roads in the industry already, but I think that we still need to let the basics to be stable and to have a good analysis of the very basic technology. Otherwise, it will be difficult for everybody to achieve a zero-carbon society. So several days ago, I paid a visit to Martin Green, Professor Martin Green. So Professor Martin Green want me to send a message to all the colleagues in PV industry that he hoped that all the people in this industry can work together, that we've known that perovskite has undoubtedly become a frontrunner for tandem solar cells. So this is the sentence and the message that Professor Martin Green want me to send over, and I would like to read it here. Perovskite has undoubtedly emerged as a frontrunner for tandem solar cells. However, its reliability and scalability remains a hurdle. The stability issues associated with perovskite, coupled with concerns about the toxicity of PB, has raised valid questions about its widespread adoption. These challenges highlight the importance of diversifying our research efforts to explore a more suitable candidate material for tandem structure and other advanced approaches. Our research as UNSW is committed to exploring alternative materials and approaches that not only address the current limitations but also pave the way for sustainable and scalable solutions. Our goal is to contribute not only to the development of high-performance PV technologies, but also to ensure their scalability and environmental stability. So we've actually done a lot of research in terms of the next stage of technical and technology, and there's a lot of research in perovskite, but for perovskite, it remains its hurdles. So for AIKO, not only do we have R&D centers and research institutes for perovskite, but also for other different technical routes. We hope that together with scientists all over the world that we can explore the next stage, next generation of solar cells that can be put into mass production. We hope that in the near future, that theoretically speaking, that we can achieve a photoelectric conversion efficiency of more than 40% and entering into a 10 terawatt era. After years of efforts, that we are entering from 0.5 terawatt into 1 terawatt. And when we are talking about terawatt, everybody is starting to accept this. And after our research, you know that AIKO, we do have our institute in Germany, and also we are building a new zero-carbon institute in Europe as well, and also we have our institute in the city of Zhuhai in China as well. We hope that all the colleagues in the PV industry, I think everybody is rather conservative in terms of the development of PV industry. In the future, after concerted efforts of all the people in the PV industry, we hope that we can make PV technology as cheap as running water and to enter into the 10 terawatt era. Thank you all. Thank you, Chairman Chen. Thank you for your insightful speech.
谢谢，再次感谢陈董为我们带来的精彩的分享。
So from Chairman Chen's speech, we have known that AIKO has a strong innovation capability and technological leadership. In the future, AIKO will insist on taking the lead in technology, quality, solution, and customer values, so that to bring higher values to the clients all over the world with better scientific results. As you all know that the PV scientific research starts from European and US, but in China we have already becoming a leader in the industry. And now let's welcome Dr. Shen Hui to give us a speech to elaborate on innovation and contributions on Chinese PV industry. Let's welcome. Colleagues from PV industry, friends and media, good afternoon. Thank you, Chairman Chen, for giving me this opportunity to learn from everybody here. I think my topic today is innovative contribution of Chinese PV industry. Just now, Chairman Chen has talked about the innovations that AIKO has made in the entire process, so I'm not going to elaborate further on this. Of course, AIKO undoubtedly that in PV industry is a very good front runner that dares to do the innovation and do the contribution. So for this, I'm really happy and glad, but I would like to elaborate more on my insights. So my PowerPoint will be breaking into the following aspects. And Chairman Chen talked about the entire history of PV industry. I would like to break in more details. So in about 1800, we have the Italy scientists founded the Volta. And that is why we have started to study the photochemistry. And in 1839, Edward Becquerel from France started to study the photoelectric situation, and because of his findings, it has already become a very strong award in the industry. So these are the top 2 awards in the industry. I'm not going to focus more on the details. So photovoltaic first application is actually in the book, and also how we started to use the different materials from seed to silicon. So the first use of it is actually that we want to solve the electricity issues in the farm, and then nobody actually considered the possibility of transforming it into the upper space. If we do not have PV technology, then basically, let alone talking about its application in aerospace. And also, we have the breakthrough from the Bell Labs, from M-Wolf, from Shockley. So in 1961, W. Shockley actually calculated the solar cell ultimate efficiency, and his assistant is actually alive today, who is still contributing to the entire industry. This cursor that on the PowerPoint. Talking about 20 to 30% of conversion efficiency. So a basic summary is that until 1961, we have a very good scientific base for the PV development industry. So here, this is the milestone work from Bell Labs, and we have like about many articles in French, in Italian, and in English. I've actually read all just to have a better understanding about the PV development. So the first paper for silicon cell is actually in the year of 1954, and then moving forward, and we've seen that people have founded the crystalline silicon, the PN junction. So in terms of solar cell, it's actually connected to the solar spectrum and different types of semiconductor materials. Up until today, we want to find the 100% of material that is better for the conversion from sunlight into electricity. But till now, we think that silicon is the best in terms of recycle, and it's considering its maturity and also its flexibility. So that's why we say that after 100 elements, the chemical elements that we have in existence, silicon is the thing that cannot be replaced. And that's why about 90% of the materials that we're using in the industry is still the crystalline silicon that we're using. So that's why in the future we say that how we are matching it back into the light spectrum is also what we need to consider. So the contributions that we have from in China, basically we're very up to the stage and up to the speed with the international stage. So you know that in 1970 we had the In the 1960s, we already have a team working on it, and we have all different professors looking into this crystalline silicon solar cell in the 80s and in the 90s as well, and also moving into the aerospace is actually with the support of our own contributions. Especially, we say that the first artificial satellite that we have is actually we're using it, the crystalline silicon solar cell as the power supply system. So that's why I would say that the solar cell is actually what makes it happen for people to go to the aerospace. Maybe in the future that we're able to have meetings in moon and in different planets. Those are all possible. So moving on for the overlapping solar cell, that is the first of its kind to go to the aerospace. So that is the progress that we have made, and I had a book that is called The Sun in My Heart. I've already summarized our contributions in terms of the development of PV industry and what we have done, and also what Chinese institutes have done for this. So now let's take a look at the crystalline silicon solar cell industrialization development process. Starting from 1974, we have Solar X, and then 1976 to 1996, we've got development from the Europe to United States, and who's taking the lead, but gradually China is taking the lead. The reason why is that for Europe and the United States, they have a really big misjudgment that they think that the silicon wafer cannot be strong enough to help with the conversion efficiency of solar cell. But China, we have realized and proven that the silicon is strong enough to support the industry, and that's why we can be able to be the front runner, surpassing United States and Europe to have a better development. And I'll skip the details in terms of the development history. So previously, the entire industry is actually small scale. It's only megawatts. But now, if we do not have a production capacity of gigawatts, we do not want to say that we are in the business. So that's how we have developed in the past years. So for the silicon wafer, it's definitely the past, the present, and also the future. And we have used a lot of thin film technology. But still talking about very basics, we are starting from the Western world, and we know that either from PERC, etc. But the applications and the final industrialization is still made happen in China, because we have the breakthroughs in materials and also in equipment, and that's why we make it happen from science, from labs to the sites. We know that when we are having the existence of a science method, to create it is very important, but to make it into the actual application is another thing. So technological innovation is very difficult, and when we are able to make it into mass production, it's even more difficult. So until today, that we know that PV is the future, and that is fully recognized by people across the world. So for the BC solar cell, it's a very long development history that starting from 1975, we already got the existence of this back contact solar cell, interdigitated back contact solar cell. And a lot of countries in Europe and the United States are starting to do research there. So in terms of this is actually an extremity that we're talking about. And it's 100% of absorption of cell. So I study both photons but also semiconductors. So I can proudly say that before getting my doctor's degree in Germany, I've got the highest grade in my theoretical study. Up until today, I'm also studying what is light when Einstein proposed this. And have we achieved extremity in light? No. Maybe we have achieved like 90% of the problems for the electricity, but still we're yet to be there in terms of the final realization of the transformation of the light. We haven't really reached about 30% of the conversion efficiency. So maybe that's the next stage of evolution that we're talking about. Maybe we need to have more Einsteins in the industry so that we can improve the conversion efficiency of light even further. To maximize the use of light, and that may be the difficulty in the future. I know that a lot of companies are doing research in terms of this, and this is where we see the basics, but a lot of them haven't really been put into mass production. The key is that some of the technologies is not fully applied into the equipment and into the production lines. So here, just quickly run through all the scientific papers and the development for IBC solar cell. And the first paper is actually from Purdue University, and of course there are the support from companies in the industry, but moving forward, I will skip the advantages of IBC solar cell because Chairman Chen has already touched upon on it. So for the entire development of solar cell, we see we have the contribution of Chinese companies, and so in the final stage, that who can actually make it into mass production and who can make it into the production lines and offer it to the clients. We see that the Stanford committee have already released some data, and we see that in 2014 we've got Trina Solar, a Chinese company, making contributions. Some projects that Trina Solar is leading, and also we've got Jollywood from China as well, Huanghe Electronics from China as well, and Longji, etc. We've seen that the contributions that some of the Chinese companies has already contributed, but of course, in comparison with a lot of different Chinese companies, AIKO is making the biggest contribution in terms of making it happen, putting into production lines, and also into mass production. Me personally, I know Chairman Chen very well because in the past he's a really good entrepreneur in making aluminum, and then in 2009 all of a sudden he transferred into the PV industry. It's a tough route for him to be choosing, but he's able to keep on innovation. That is something that he's really good at. So I'll skip the facts, and I hope that AIKO can moving forward in terms of crystalline silicon development, in terms of back contact technology. We see that there are a lot of existing problems in terms of materials, in terms of process. How can we making breakthroughs? Those are the parts that I hope that we can achieve. And how can we put the theories up in the sky to down onto the earth? That is how we can making contributions as well. So here, what I've analyzed as the 5-step of development for the Chinese PV industry. First is the crystalline silicon solar cells, moving forward to mono-polysilicon wafer, to polysilicon materials, to the PV power station technology. So now, what is the new solar cell? What is the new PV technology? Who is going to take the lead? Chairman Chen has already mentioned, shared his concerns. So we have already making into products, but what is the next generation of development of the industry? What are the breakthroughs that we can making through? I think that for the entire PV industry in China, we starting from zero till now, we have already made a lot of things happen. We have already created a lot of achievements and contributions. This is not something that I'm bragging about. This is actually the head of SolarX. who wrote a book about PV development. He used 2 chapters to talk about the miracles that China has made. And also he wrote this book and published it in United States, and he actually put some Chinese characters in this book to talk about the miracles that China has made. So for us, we Chinese people, in terms of the equipment manufacturing and some of the breakthroughs that we have made, we are already making a lot of contributions into the industry, including the polysilicon materials, into the wafers, into the bars, etc. We have really done a lot of different contributions, of course, and also our production line craftsmanship. And for one factory, it's basically 10 gigawatts capacity. This is something that a lot of Western factories would be difficult to imagine. And also for the theories proposed by Martin Green, we're actually putting a lot of technologies actually into the production lines. So not only for PERC, but also for TOPCon, that is also the case. And for heterojunction, a lot of our suppliers, in cooperation with the PV companies, we are also see how we can make the technology into production lines. So till today, I would say that a solar cell is only a technological advancement. We haven't really got a new theoretical breakthrough in terms of theory, especially for the photon perspective. If we can have more breakthrough, maybe we can even exceed 30% or 40% in terms of the theoretical limit. So I don't think about how many generations in the future. We only have one generation. It's just how we can improve. And I would say that the silicon solar cell, we still have many years to come in terms of our development. So I think that the Chinese PV industry is very competitive, and we can build a confidence into the overall development in the world. But still, we need to worry, and that's why we need to move forward. So I come from the Yangtze Institute for Solar Technology. I hope that I can advocate and to have everybody in the industry to help us to do more, to contribute more, so that we can have a better success in the future. Thank you.
Much for the wonderful speech of Mr. Shen. Please take your seat. The PV technology has now, we know that has become a brand for the Chinese enterprises, and AIKO is going to work together with the global leading experts and R&D resources to become the leader of the industry. Now let's give the floor to next speaker, Dr. Frank Feldman, to come to the stage and share with us the innovative outcome of AIKO. As one of the inventors of TOPCon, Dr. Frank is going to share with us the new information.
AIKO Europe and the inventor of TOPCon to come to the stage and share his speech. Please welcome, sir.
Dear valued guests, dear Chairman Chen, it's my honor to be here today and to present to you the history of the development of TOPCon cells, which we initiated at Fraunhofer ISE, and I will show you, of course, also the future of this technology. And here you can see a picture of my younger self when I was awarded with Udo Römer from ISFH, the Junior Einstein Award from Solar World in 2016 for pioneering polysilicon contacts for PV applications. And here on the left-hand side, you can see my first paper, which was published in 2014 on the TOPCon cell. But before we dive into the TOPCon cell, let's have a look at where we are right now. I guess you are a bit familiar with the graph on the right-hand side, which shows the learning curve of the PV industry. And so in average, the cell efficiency has increased of about 0.5% in efficiency over the last 10 years. And one learning from the past is also that new technology, of course, has to offer an efficiency benefit, but only it comes into the market at when it also has only a moderate increase in cost, as it was with PERC, which had 2 additional process steps compared to aluminum back surface fields. And now we see that PERC efficiency saturates, and new technologies featuring passivating contacts are taking over. And so there is no way around TOPCon, but also we are very proud to be above the race with our all-back contact cells, where we can achieve a 26.5% cell efficiency, and with that we are very close to the practical limit of silicon solar cells. So talking about TOPCon, so here you can see a sketch of a cell structure. It features a boron-diffused emitter at the front side, which is well passivated with aluminum oxide and silicon nitride. And at the rear side, recombination is effectively minimized by a stack of a thin tunnel oxide and a heavily doped polysilicon layer. And when we did that work at Fraunhofer in 2013, then the unique thing about this technology was that we could actually show that we have an efficiency benefit when using passivating contacts. So the first cells had an efficiency of more than 23%. And what was also unique is that we were used for the first time the PECVD deposition technology to create the polysilicon contact on the rear side. And today in the industry we see two mainstream technologies for TOPCon, and this is on the one hand side LPCVD and the other hand side PECVD. So let me guide you quickly through the main process steps for making a polysilicon contact. So here you see a sketch of a symmetric lifetime sample. The first process is to grow a very thin tunnel oxide layer on the order of 1 to 2 nanometers. We can use different means. Most popular is the thermal oxidation for the tunnel oxide. Thereafter, we deposit a doped amorphous silicon layer, and here we can use various methods like PECVD, LPCVD, or even sputtering. The third step, which is important, is the high temperature anneal, which leads to the crystallization of the polysilicon. We also then effectively activate the dopants in the polysilicon. We see also dopants diffusing at these high temperatures, also in the silicon. But here we need to make sure that this process is very well controlled, and fortunately the tunnel oxide acts as a diffusion barrier here. And a third mechanism which occurs is that we form tiny pinholes in the tunnel oxide which facilitate charge carrier transport. And last but not least, we need to have a hydrogenation process to effectively passivate defects, especially at the silicon-silicon dioxide interface. And here it proved to be very effective to use atomic hydrogen instead of molecular hydrogen. And the industrial process sequence, I mentioned it before. On the one hand side, we have the LPCVD process, where we typically deposit undoped polysilicon onto the tunnel oxide, and then we dope the material by epochal diffusion, or we go the other way with PECVD, where we deposit phosphorus-doped amorphous silicon onto the tunnel oxide, and then we crystallize the structure by the furnace anneal. And for the hydrogenation, we deposit dielectric layer like silicon nitride via PECVD, and then in the fast firing process, hydrogen is released from the layer and effectively passivates defects. So the high temperature anneal is important for the TOPCon structure because it forms the contact, and if we are in optimum annealing range, then you can see that we get low recombination values shown in green, and also reasonably low contact resistivity values. And here at my time at Fraunhofer, we took an TEM image of such a contact, and you can see that the tunnel oxide is nicely intact. It's very thin, just 1.1, 1.2 nanometers, and continuous across the surface. And on top in green, you see the polysilicon layer with the different crystal orientations. However, if we go to too high temperatures, then two adverse effects happen. On the one hand side, we drive in too many dopants in the material, which increases the recombination. And if we go to excessively high temperatures, we even see a huge deterioration of the tunnel oxide layer. And then you can see what happens here. This is a worst case scenario, that the tunnel oxide layer balls up and the silicon layer on top of the crystalline silicon can epitaxially regrow, and we virtually do not have any surface passivation left. So now let me spend a few words about TOPCon cells. Here you can see the laboratory-like TOPCon cell, where now in the latest version we had nicely structured evaporated metal fingers, which have a feature size of just 8 micrometers, so that we have almost no metal shading, which enabled us also to get a very high current for a both-side contacted cell. In green you can see the development or learning curve, where we got quite quickly to 25% efficiency, and then it took us some years to get to 26%. And now a few years later, there was quite some R&D activity in the industry, especially here in China, to industrialize the TOPCon cell, which is the industrial version is by nature bifacial. We have screen printed contacts on both sides, and you can see here with the blue dots the impressive learning curve, where we now are also for champion cells at 26% efficiency. And so this slide I borrowed from Chen Yifeng from Trina Solar. He gave a talk in 2019 where he compared the challenges of industrializing TOPCon with the challenges back in the day for PERC. And so at that time there were quite a lot of questions open. So how to realize the cell, which is the best method to deposit the tunnel oxide and the polysilicon layers, which is a suitable metallization technology today. The favorite technology is screen printing, but also still plating seems to be a viable candidate. Now I would like to talk a bit more in detail about a few challenges during the development. So when going to large area, then especially with LPCVD deposition, you have to deal with the wraparound of the layers, so that there is a deposition at the edges, but also on the front emitter. And you have to carefully remove the wraparound without over-etching the front emitter. If you, let's say, etch too little, then what happens is that you basically create, in the worst case, a shunt, or as you can see from the graph on the right-hand side, you have a very high leakage, a very conductive leakage path at the edge, which gives you very high reverse currents. So such cells, although they might have a relative decent efficiency, cannot be brought into the module, because then you would have hotspot problems. Then another topic which was addressed was the development of the silver paste for contacting polysilicon layers. In the beginning, standard silver paste for contacting phosphorus-doped emitters were used, and these quite readily fired through the even thick polysilicon layers. But with each generation, the paste makers improved the paste and got a better understanding on how to design the paste so that it minimally penetrates the polysilicon, and today we can contact polysilicon layers as thin as 80 or 90 nanometers without suffering from enhanced recombination losses. Then another challenge was that there was an imbalance between front side and rear side recombination, and that was mostly due to also non-optimized contact formation, especially at the front side. So at the front side we have silver aluminum paste, which typically needed higher firing temperatures than the rear side paste, and we saw at Fraunhofer that we need a higher temperature to get a good fill factor, but then, as you can see on the graph on the upper side, higher firing temperatures also led to a decrease in the VOC, so there was quite of a trade-off, and such cells were strongly limited by recombination at the front side. But fortunately also a solution was found for this, and with now laser-induced fired contacts, which are fired at the end of the process sequence, we can really minimize contact recombination at the front metal contacts as well. And another important aspect, which has also been mentioned beforehand, is the wafer quality. So boron diffusion typically takes place at 1000 degrees centigrade, and then this can be lead to quite fast formation of oxygen rings, as you see here in the upper PL image. And an important step towards wafers free of oxygen rings was to process wafers with a very low interstitial oxygen content in the order of 10 ppm. And now I'd like to discuss with you the loss analysis of a TOPCon solar cell, as it is representative of a production line, has an efficiency of 24.7%. A high VOC of 720 millivolts, which is 20 millivolts higher than state-of-the-art PERC cells. The blue and green bars represent the recombination losses, and you can see that most losses still occur at the front side. Additionally, we have transport losses at the front side, and so the question is, how can we improve upon this? And in 21, my former colleagues at Fraunhofer and me, we published a paper on the top core cell, where we switched the material from N-type to P-type, and now we can omit the full area boron diffusion at the front side. Thereby we get a higher VOC, which translated also in a higher efficiency of up to 26%. And so I've simulated here a TOPCon Plus cell, which features polysilicon contacts both at the front side and the rear side, and these give us a boost in VOC to close to 740 millivolts. We also have improvement in fill factor. So, and now the question is, of course, how can we get even better than this cell? And when we look into the loss analysis, we see that we are still limited by parasitic absorption, especially in the front polysilicon fingers, but also by metal grid shading. And that leads us to the all-back contact solar cell, which has been successfully developed and launched by AIKO. Here we achieve an even higher VOC and a remarkably high JSC of more than 42 milliamps per square centimeter, which gives us an efficiency of 26.3% and more. And with this, I would like to conclude. So, for me, efficiency is the main driver to reduce levelized cost of electricity. With our ABC solar cells, we have a very high efficiency and are approaching slowly the practical limit of silicon single junction cells. I believe that TOPCon Plus cells are a viable upgrade over TOPCon, and at AIKO we believe that per production lines can be retrofitted to produce TOPCon Plus cells. Thank you very much for your attention.
All right, much appreciation for Dr. Fran for insight for views. Thank you so much. Please take a break. Thank you so much. 谢谢。谢谢，再一次感谢 Frank 博士我们带来的 TOPCon 以及技术全貌解析。我们可以感受到爱旭真的是在各主流技术路线上都有着深刻的布局，值得我们共同来期待。那么接下来让我们有请出爱旭股份副总经理夏恒亮先生为我们带来的重磅新发布讲，为您好请本身 ABC 组件，掌声有请。
Digital Energy to give their presentation. Welcome.
Thank you. So first of all, I do thank everybody to join us in terms of our product launch in this cold winter and to talk about the 10 terawatt era. Last time we met is actually in SNAC in Shanghai when we talked about ABC technology after half a year of development. I believe that you've already known that what is the breakthrough that we have done in terms of ABC, and we are very happy to have this opportunity to share with you about our latest progress. So today my presentation is ABC module, born for scenarios. So when we develop technology, the final stage we want to have is to create values for customers, and that is where we root from. So in this PPT you will see that in 3 scenarios, finally we are able to cover 3 different scenarios, from utility to CNI to residential. So you'll see that in ABC 2 years ago, maybe a lot of people are doubting that if we can make it happen. And 1 year ago, you might be worrying about that whether we can have the bifacial efficiency. But today, we're very happy to answer your doubts. So now let's take a look at our broad product series after 2 years of development for these 3 scenarios, from utility to CNI to residential. We are able to have the full coverage and the final upgrade, and this is the first topic I would like to elaborate on, and that is our second series of products and what our upgrade. Let me go through them one by one. The first is a higher power. So you'll see that for the entire ABC module in the first half, in May till now, after half a year of development, our power in terms of utility, we are improving from 615 watt to 640 watt, and the competitive increasing in different scenarios as well. And the second is a very important technology, that is the partial shading. And let's take a look at the video first, and then I'll elaborate on the details. So you'll see that on the left-hand side is ABC module, on the right-hand side is the traditional modules, and with different shading, what is the comparison of the power that we have. With 2-part shading, the ABC module can still guarantee more than 90% of the output, but under the same scenario, the traditional module will only have a guarantee of 40% of the power output, and having more shading on, then ABC modules will having better performance compared with the traditional modules. And when we are covering 6 parts with shading, then you'll see the high comparison. With 6 parts shaded, then ABC module can guarantee a 60% of the efficiency, and for the traditional module, basically there is 0 output. And you'll see that is the extreme situation where we are blocking the 2 serials, that ABC module can still guarantee 60% of the power output, and the traditional module is basically a dead end. So previously, our branding department had made a very good-looking video, but I did not want to present it today with you because I still want to show you the data, the final practical video that we have, so that you can take a look. And if you want to do this test, you can take a look back in your company as well. And it's just connected to the water pump, and then you'll see the difference. Maybe you are very curious how we make it happen. So another video that I want to present. So you'll see that when we're having the shading, the traditional modules on the right-hand side, the bypass dial will be deactivated and this part will be dead end. But in terms of ABC module, because we have our innovative pattern design, if we've got two leaves putting on the module, then only those two parts that is shaded by the leaves will be unfunctional, and the rest of the part in the entire serial will still be working and functional. And on the right hand side, you will see that is our test comparison. So our power output in terms of ABC module, we can still guarantee a 90% of the power output, but for the traditional module, when we're talking about TOPCon, maybe it's only about 59% of the power output. And also we do have a lot of like real case scenario I will talk about later on. And another very strong function is the high temperature resistance. And let's just take a look at another video first. So we have done a comparison when our module is shaded for 1 hour and what is the temperature of the module. You'll see that for the traditional module, the temperature is up by 100 to 140 Celsius degree, and for ABC module, the temperature increase is within 100 Celsius degree, and we have already done the TUV certification for that as well. So what will it bring? So you know that the hotspot and the crack is a very strong issue that we have. If we have the crack, we have the hotspot, it will influence the efficiency of the module, and if the temperature goes up, then it will influence the conversion efficiency of the module as well. If we can control the hotspot, then this will bring us a better guarantee in terms of our efficiency when we are creating the modules for the clients. So that is one of our strong points as well. So the next part is a better temperature coefficient. Here we also have a third-party certification that our second generation of products can achieve a negative 0.26% in terms of 1 Celsius degree. And what will it bring to our clients? You'll see that in extreme weather conditions in the southern part of China, when we have more than 40 Celsius degree of weather, then the ABC module power output compared with traditional modules will have 2.2% of higher output. And that means that the higher the weather condition, the better performance will ABC module perform. And here in this page, as I've just mentioned, that this year we have increased our bifacial rate. Maybe half a year ago, when we talk about ABC, a lot of people are doubting that if we can make bifacial ABC module, and we're happy today that we're giving you a result and feedback that today we can achieve a higher bifacial rate by 70%. So what are the values that we can create, and what are the advantages that we can bring forward? Now let's take a look at 3 different scenarios. For example, for the utilities scenario on the ground, on the water floating scenario, and on the water pile scenario, we can on average have efficiency increase by 5%. The power increase by 5%. So how can we make it happen to achieve the 70% of bifacial rate? We have several innovations. The first is the innovative pattern technology, and the second is we have used some new materials, and the third is some optimized structure. So later on in my presentation, I will share more case studies and what are the actual values that we'll bring forward. So just now, I've basically summarized the upgrade of ABC module. In summary, first of all, higher power. Second, optimized partial shading. Third, high temperature suppression. Fourth, better temperature coefficient. The fifth, better bifacial rate. Just break it down that what are the values that we are creating to the clients in terms of our products. So today I'm very happy to present the products for utilities with the bifacial rate of more than 70%, and I'll have our colleague to present you the two new product launch that we have, Series and Polaris. Let's take a look.
So
you'll see that those are the two new products that we have launched. That what are the specific features? I will elaborate more. So first of all, some parameters. We know that for ABC module that we are famous for our efficiency. So for the utility efficiency, that we have the power that is more than 640 watts, and our bifacial rate is more than 70%. Under such circumstance, that we are still able to introduce our second generation of technology into our products, including the partial shading, the high temperature suppression, and the anti-cracking. Those are all putting into these two new products. And just now, and also for mountainous areas and for waters, we have new products as well. So for on the right-hand side, the series for the water scenarios, that what are the things that we have introduced? That we have the high resistance water encapsulation technology and anti-corrosion frame, and also waterproof cap, so that we can avoid the water to influence too much on the module. So for the waterproof cap, this is a very simple change, but we can bring in better advantage. So for example, if we are putting a module into the site that we keep it there for 2 months and we are not using it, installing it, then how can we prevent the water into from going into the module surface? And that is what we can do through those 3 different technologies that we have. So for the water size, we have series. In terms of the integrated power station scenarios, what are the challenges that we have? First thing is that maybe you'll see that we have a scarcity of land usage. It's difficult for you to get the land, but how can we make full use of the land resources? And the second is when we are having a really high BOS cost, and when we talk about the maritime PV, the water PV, the floating PV, on those flexible scenarios, that how can we reduce the BOS cost? Then we can improve the economic features. The third challenge is that, especially in the bushes, where we have the accumulation of dirt, and also we have the bird increment to shade the modules. This is another advantage. The fourth one is the difficulty in terms of operation and maintenance. How can we lower this O&M difficulty? Those are the challenges that we're looking at.
So we're always thinking that for different scenarios, we should have a different solution, and We'd like to talk about how to maximize the value of different scenarios. So first, we can see that with the limited area, for the installed capacity needs to be improved within this limited area. At the same time, we should think about that with the same installed capacity, how can we use the limited, how can we minimize the use of the land? You can take an example. For example, there's a power plant with 100 megawatts. We use TOPCon and ABC. So for every 100 megawatts, we can reduce 105 move of the area. At the same time, for this installed capacity on the same area can be increased by 5.8%, especially at the coastal areas within when there is a very limited area. We need to make sure that we can maximize the value with the limited area. Just now, we also mentioned that in more and more scenarios, there is the boss cost. So how to greatly reduce the boss cost is something we are thinking about. So among the boss cost, there were several aspects, including the track and support and the installed the foundation and the site and premises, etc. So we have a use our equipment, we can reduce about 50% of the boss cost for the single watt. So one is to reduce of the cost of the support and also the foundation and the site equipment, and also we can reduce the cost of the booster station. So for the ABC and for the customers, we can all bring the values. So we can reduce the cost of 5% of the amount of the modules. We can also see that for the power station at the onshore shoals and the fishery area and the mountains, we can all reduce the cost for 20 million, 15 million, and 12 million for different types of scenarios. So this has a very strong competitive advantages in terms of the cost. So we also like to talk about the higher output of the electricity. We've done a comparison with the TOPCon. The power generated under the same area can be improved by 7%. We can also improve the power with the same area. So when we can increase about 7%. So one is to improve the power, and second one is to reduce the attenuation rate. So 1.5 point will be reduced within the life cycle. Another one is the optimized temperature coefficient. So we can reduce about 0.6%. Being reduced. So for the high temperature in the summertime, we can have more advantages of this optimized temperature coefficient. And number 4 is that we can optimize the function of the partial shading blocking function. So we'd like to share with you about optimization of this shading. We've done some live tests. We also welcome all of you to do the comparison with us with the different scenarios with different shading. What are the differences caused to the power generation? So the first photo is about the example from the Japanese client. They've done the ABC with themselves and ABC with and without shading and blocking. So we can see that what is the theoretical value and the actual value. We can see there's about 30 to 60% of the differences. And second is an example about the local partial shading. We can see that when the shading are the same, we can see the difference of the output of the power, which is 20 to 60%. We also have a comparison between ABC and TOPCon. So when there are shading of the trees, we can see over 15% of the power generation from ABC. And then we can also see the soiling at the edge. There were 2 to 4% of the higher the power generated by ABC compared with the traditional models. So for this ground power generation power plant, we are always thinking about how to reduce the maintenance operation cost. So we need to think about what are the costs, so including the hotspot and the fingers from the front. So from these three aspects, the malfunction may account for 40% of the efficiency of the whole modules. So we can have this high temperature inhibition function. They can also greatly reduce the possibility of the malfunction of the modules. At the same time, due to the high performance features of ABC modules, we can make sure that within the same installed capacity, the number of the modules can be reduced and the connecting points can also be reduced. So in this aspect, we can effectively reduce the cost of O&M. We would like to share with you an example. This is from Guangdong, which is about the centralized program of 380 megawatts. We're thinking about what types of the modules we should use. So we can increase the 7.8% of the power within the same land, and the revenue also has been increased by 380 million RMB. And now people have the requirement about the green license and the CO2 emission and reduction. So in this way, by using our modules, we can also help to get the benefit of over 50 million RMB in terms of the revenue from carbon emission. We can also make sure that compared with the traditional TOPCon method, these LCOE can be reduced by 4%. So these are the direct benefit, but there are also the indirect benefit. So since this power plant is developed and constructed at a shore area, so the bird feces and the high temperature is very are very destructive. So by using our models, we have used a technology which is a resistance to the erosion. So this can help to reduce the O&M cost and help the clients to greatly reduce the cost in the later stage. So that is why the project at the shores, not only we can greatly reduce the cost of LCOE, but also we have the benefit, indirect benefit. To review that for the ground power plant, we can see the cost of we can see that LCOE can be greatly reduced. At the same time, the near shore and the different areas, the cost can be reduced by 4.2%. And here I would also like to share with you that for the ground plant, we are used the standardized scenario, but for every scenario, they have different types of the challenges and pain points. So how to use this scenario-based product and solution to guarantee that the ground power plant have the lowest LCOE and highest revenue. This is also something we'd like to share with you and discuss with experts and guests. So since we have the very low attenuation efficiency and the shading and high temperature inhibition. So all these features can help this centralized and ground power plant can greatly reduce the cost. So when we talk about this ground scenario, we would like to talk about the industry and commercial scenarios. And the biggest challenge is about the dual carbon requirement is more and more strict. So within the limited area, how can we generate more green power is the major challenge we are faced with. At the same time, since the temperature at the roof is really complex, so we need to think about how to use every single inch of the land and to greatly reduce the efficiency of the power generation is something we have to think about. And now I can see there were higher and higher numbers of the clients from the commercial and industry areas, but we need to think about how to provide them with the ABC module solutions. So what we have done is that with the same areas of the roof, we can increase by 5.8% of the installed capacity compared with TOPCon, and the 7% more of the green power, since there is a very complex scenario of the roofs and there are largest area of the shading. We have to think about better utilize these shading areas and to maximize the power generation. And also for the O&M, for the ABC, it has the very good performance of for the protection from these hidden cracks, so we can overcome these difficulties, these challenges. In terms of the commercial and the business scenario, for this comic series, we are also upgrading all these comic series. So not only the power can be increased, include ABC can increase the delivery power to 630 watts. At the same time, due to the partial shading optimization and protection from the hidden cracks, we can greatly overcome the challenges in the industry and the commercial scenarios. I'd like to share with you an example, which is from Zhejiang province. Seven projects together is about 40 megawatts, and by using ABC modules, the installed capacity has been increased by 5.8% on the same rooftop. So the initial investment is higher, which is about 8 million, but the time and the return period is the same as the previous modules. So within less than 4 years, we can cover and collect all the investment. And after that, every day the revenue is higher than that has been generated by the traditional technology. So within the same life cycle, the benefit is more than 7.9%. So for the commercial and industrial scenarios, what we are talking about is with the same investment, we can think about the higher return of the investment. This is also the biggest value we would like to provide to the customers and different scenarios. Many customers are discussing with us that under the industry and the commercial areas, the price of ABC modules are higher. So whether it takes a longer time for us to recover the investment, but today we can answer the question. This is a project which is about to be delivered. And this is say household scenarios, and currently the biggest challenge and difficulty is that in rural households the development is very difficult, and each single panel is about 800 to 1,000 RMB, and it also very competitive in the market. And also we can very well use the south and or north slope of the roof. Currently we are not using the north slope, so when we are developing one roof, we can do the things of the two sides. Another one is about the shading. We may see this blocking of the light from the woods and from the trees and the chimney. So we need to think about how to minimize this loss of the power generated from these two aspects. And also safety and security is very important and cared by the general public. So first we have to prevent the fire, and the O&M should be simple, and we should solve these problems in terms of the modules we provide to the customer. So what is the solution of ABC? So compared with the traditional ones, we have the one time of the development. So for the same roof, the capacity can increase by 18%. And the temperature coefficient, especially in the southeast coastal areas with high temperature, this power generated for a single watt will be increased by 3%. And number 3 is about the shading, and from the trees and the differences of the lightings at the south and the north of the slope. We can use this function to make sure that these shading areas and the slope at the south and north can be used effectively. So by developing one household, we can have installed modules of the 2 roofs. And another one about the safety of the rooftop. One is the high temperature inhibition function. We can also prevent the problem which are caused by the high temperature. and the fire caused by this. And we also have the function of the protection from these hidden cracks. So the modules are mainly at the slopes. So if the installation is not very good, then the tension would be very high. In this case, there will be the hidden cracks. So you can see after 1 to 2 years, these hidden cracks, the ratio is really high after several years of use. But use ABC modules with this performance of anti-hidden cracks, we can improve the safety and the fireproof of the roof and to reduce and to make sure the O&M will be much simpler. In China, in the scenarios of the rural household, we are providing the high performance ABC modules, and we can see that these very special features can be embedded into the household scenarios. We hope that in this distributed scenario and household scenarios, not only we can use the good modules, but also for the latest technology can also be used in this distributed power generation scenario. So for a case sharing, for a roof with an area of 100 square meters, we use 40 modules. If we use ABC, is 78, we can see the dealers and the platform dealers would think about for one time of the development, the revenue can be increased by 18%. That means that development cost may be 14,000, and also the development fee of the single watt is reduced by 15%. In terms 15% in terms of the investors. For one rooftop, within the life cycle, the power generation can be increased by 25%. That means for a roof in the whole life cycle, we can have over 60,000 RMB more of the revenue. So this is increasing the value, and this is also what AIKO is looking forward to. So under different scenarios, we can realize the maximum of the value. I would also like to share with you the scenarios of the application in Europe. Several challenges we have now. Number one, the perfect combination of PV and construction. So the architecture is something which cared a lot by the European users. And in Europe, we know it's a general trend of a shift from gas to electricity. But the areas that the rooftop is limited. So how to maximize the power generated within the limited roof area. Number four is the complex scenario, complex architecture structures and the shades. So the shading is a very common problem, especially in the Netherlands. They would use these optimizers to solve the problem. But we found out that by using this function of optimizing the shading of ABC models, it can greatly solve the problem. And also for the safety of the rooftop, we have brought to this product. So the new generation of the household product has the following features. Number one, the performance has been greatly improved, but the area is just 2 square meters. The product features including the local and partial shading and the anti-hidden cracks performance and high temperature inhibition functions. We hope that they can all be used in these distributed household scenarios. These parameters are just fingers, but they can bring the very concrete benefit to the households. So this is an example from the Netherlands. This is a rooftop with a family of 4 members, and per year the power is about 8,000 to 9,000 kilowatt-hour, and 4,000 are for basic needs, and 1,000 are for the charging of the EV, and the 370 are for the heat pump. So for the heat pump, the consumption of power is 700 kilowatt hour. So we hope that how can we cover this power needed for a household, which is about 8 to 9,000 kilowatt hour. We've done a comparison of ABC and the traditional modules. So the installed capacity can increase by 12%. For the whole life cycle, the power generated can be increased by 20%. At the same time, you can see that in the whole life cycle, of course, the price of N-type is higher of ABC than the PERC, but we can realize recovery of the investment within 3 years. But in the whole life cycle, the benefit will be more than 20%, which is about 10,000 euro. So these models, the cost is about 6,700. So in the household utilization, not just about the appearance, but also we are more concrete advantages. So within the same life cycle, the ROI would be higher. So that is why in the Netherlands, in the household utilization scenarios, we are rapidly seizing the market. Now let's review the major value propositions. So when we have better ABC modules, we have different differentiated products for different scenarios. And for the ground platform with the lowest cost, we are making more efforts to realize the lower LCOE. In the commercial and industrial scenarios, we can realize the better revenue or income within the same investment period. And for the household users, generate more power. We can pay attention to the beauty of the architecture and the roof safety. I'm very happy that we have shared with you 2 aspects. One is about the full upgrading of ABC modules and 5 major performance, and also the application for different scenarios and the values we brought to the customers, and we share with you the cases. So we believe that in the near future, we can develop the further generation of the product, which is the lightweight modules and the small modules. We really would like to invite you for your future attention. Thank you very much for the wonderful sharing. Please take the seat.
So we've seen that AIKO not only in PV technology has many very good achievements, but also is creating products for scenarios and bringing greater values to clients, and to provide customized products for clients so that we can have a stable and better beneficial benefits. Now let's welcome Mr. Zhang, the General Engineer of Energy China, to have a bit of analysis of N-type ABC module in different scenarios. Welcome. Distinguished leaders, dear experts, I come from Guangdong Energy China, and I'm a general engineer. So today I bring forward a lot of questions, a lot of question marks, and I'm here to study. So my topic today is N-type ABC modules selection in terms of module type and the value analysis. My PowerPoint is divided into 3 different parts. The first is the recent new energy policy and the PV development trend. The second is several characteristics of the applications and the technical requirements for the selection of modules. The third is the economic analysis of several scenarios. First of all, the policy and the trend. Now let's take a look at the world. In September this year, G20 summit was held in New Delhi, India, and the G20 has agreed that by 2030 that the global new renewable energy capacity should be doubled. Last month, President Xi, together with President Biden, has reached an agreement on the Sino-US agreement that by 2030, the installed capacity for renewable energy should be tripled, and by the very last end of last month and till the early of this month in COP28, then there is the more detailed agreement on the COP agreement, and also for the Belt and Road Initiative for the entire European Union. We are also elaborating on the new energy-related policy and also wanting the new renewable energy industry to be more independent. And moving on, some data that we have across China, by the end of October, we've seen that the installed capacity, cumulative installed capacity, has reached about 1.4 billion kilowatts. And in terms of this, we do have the increment in terms of PV and also for the hydrogen PV as well. And for the newly installed capacity, it's 142 gigawatts, increased by 144%. So for the entire power output until October, the entire power output in China is already 2.3 trillion kilowatts. That is taking about 31% of the overall national power output. So I would estimate that by the end of 2023, then the overall power generated from PV will take about 30% of the overall power output. That will be more than other different renewable energies. So from this data, we'll see that for us, basically speaking, when we are using electricity, every 20% comes from renewable energy. So that's why I do thank all the colleagues and your contribution from renewable energy, especially the contributions given from PV industry. Previously, we are focused more on the coal combustion and also nuclear energy, large-scale power stations, etc. But now we are laying more focus on the renewable energy and also especially for PV and solar energy as well. So for us in the industry, we are very shocked by the contribution from solar cell. We did not expect it to go this far until now. And in terms of the investment, by the end of October, the investment for all the renewable energy is about 6.21 billion RMB, and that is increased by 43.7% comparatively. So this actually solves a lot of social issues and also creating a lot of jobs. So here I would like to give you more data that for the power grids, investment is about 33.31 billion RMB. That is increased by 6.3% accordingly. And this investment increase is growing slower than that of the renewable energy investment. So that's why the country is promoting a lot of different policies and activating a lot of different plans. Moving on, what is the latest development trend? And I've talked with some of the consulting agencies that they are estimating that in 2024, the global newly installed capacity will be much slower into a rather radical growth, but it will continue to grow in the following years. So when we are talking about the PV application in fishing, in agriculture, etc., a lot of leaders, they are considering not only the development of renewable energy, but also how it's influencing the development of the relative industries. So a lot of different places in China right now, we have a lot of projects that is involving the renewable energy and also the PV installation as well. I think this is a really good trend, and this will be a norm in the future as well. And although we have different requirements, but still back to the policy, there's a latest policy on December the 7th. The Agricultural Department has published a new policy in terms of fishing PV and the requirements. In this policy, policy, it has specifically mentioned that when we are using PV in fishing grounds, the policy required that the entire area that is using is less than 40%. Previously, the figure is about 60% to 70% in the application of PV in fishing grounds. So by decreasing this figure from 60% to 40%, that means that we have a lot of more breakthroughs that we need to consider. And now let's moving on to the second part of my presentation, that is the scenarios that we have and what is the characteristics that we want to have in terms of different modules. First of all is for deserts, Gobi deserts, and what are the requirements that we have for the modules. For this, we really need to have a strong capabilities of the modules. For example, if we have like high temperature difference for the weather conditions, then we need the module to be more stable and to undertake higher temperature differences. And also, this year there is a new regulation for the applications of modules in deserts. The second is for mountainous areas. You'll see that we have a lot of mountains and they are rather complicated in the heights and in the sunlight absorption, so this will require the modules to undertake very high wind. So when we are putting modules on top of the mountains, we need to consider not only the light but also the wind. So when we are having a strong wind speed, how to make sure that the module, first of all, is secure enough, but also on the other hand to promote a lot of output. And when we are talking about our mountains, sometimes we do have a lot of trees, and especially in the summer season, that the trees will have a lot of like cottons to be generated in the air, and then those materials will be laid on the module surface, and also where we have a lot of birds, we'll have the bird excrement on the surface of the PV module as well. Those are the considerations that we need to look into when we are choosing the solar panels. And here I would like to talk more about putting solar panels in fishing grounds, especially in the southern part of China, across the sea level, where we have a lot of projects for the solar power applications. The biggest difficulty that we're faced with is, first of all, an example that in one place in Guangdong province in China, just several days ago, I had a project that the rental that they have is 2,600 per and this rental keeps increasing every 5 years. So when we are talking about such a large space of fishing ground, only 40% of them can be used for PV panels. Then what are the considerations that we need to have when we're selecting PV panels? First of all is to consider the efficiency. Of course, the higher the efficiency, the better. And the second is that for each square meter, of course, we need to have the maximized power output. And under such circumstances, then we need to consider that in the PV application in the fishing grounds, the other aspects. I would like to talk about one of the projects I've done before, that when we were transporting the PV modules on site to the fishing grounds, and overnight there's heavy rain, and we'll see that the rain is dropped onto the PV modules, and the PV modules are soaked in water. So that's why today when I look into the previous presentations, that when you guys are releasing the new products for water scenarios, in that case we don't really need to worry about PV modules under extreme weather conditions in raining days. The third aspect is that when we talk about fishing grounds, we need to consider about the wind, especially in typhoon days. And also whether it's possible for us to use the flexible mounting. If we want to use flexible mounting, then we need the module to be stable enough. So we need the PV manufacturers to tell us that under such wind pressure and also under different level of typhoon, whether the PV module is stable enough to overcome such weather conditions. And then on top of this, this, we will give further requirements to the flexible mounting manufacturers. So what we need the PV module to be able to have is that under extreme wind conditions, that first of all it can be strong enough to not crack. The next part is about the temperature, especially in the coastal areas. In summer days, we are having really a high temperature. So what we expect is that the PV modules to have strong durability in terms of salt, mist, corrosion, and strong anti-PID capability, and whether we have strong performance on the above-mentioned part. So upon solving all the above-mentioned problems, there would be a better choice for the fishing grounds. The next part is for the maritime PV application. Just now we've touched upon the water-related scenarios, and we have already able to install enough PV modules on the sea level that is easier to install PV panels, and for the rest of the areas, that is where we have the difficulty in terms of installing PV panels. For us as the Design Institute, of course we want to build as many coverage as possible, but under the current situation, we still have a lot of expectations to the PV modules. First of all is that whether the PV modules can endure high salt mist, high humidity, high wind load, and high current impact. So those are the strong capabilities that we would expect the PV modules to be able to endure. And we as the Design Institute, we want to know that if the PV manufacturers can be able to produce us with the PV modules that can undertake C5 or C6 levels of impact. And from what I've seen today, I'm really shocked at the performance of the modules that AIKO panels can provide. And also recently we are doing a lot of wind turbines on the sea level, so we're also considering the combination as well, and we are raising the requirement for PV modules on maritime as well. And here, moving into the integrated scenarios, first of all, for the rooftop, for the CNI scenario, this is a very detailed application for each rooftop. We do have different electricity pricing, so each rooftop we cannot sacrifice it. So that's why we hope that for each square meter that we can have the strongest installed capacity. And I've met with a lot of rooftops that, whereas they have strong shading, and for a lot of rooftops that we really want to put the PV models on top of it, but we are still worried about the hotspots, we're worried about shading, etc., and how the temperature is going to influence the efficiency of the modules. So once we have better performed PV modules available in the market, then it will be easier for us to try to put them on the rooftops of certain areas, and then we can increase the usage of the rooftops so that we can create more CNI scenarios. The third part of my presentation is to do some economic analysis. Frankly speaking, for ABC modules, I do not really have a lot of research into it. So I've got several detailed figures, and some figures have gone from the market, and I've done some simulation and some analysis. Under the same area, same size, we compare the efficiency. Of course, we know the efficiency has been increased. for the panel under the same area, the efficiency of course is improved, and under the same area, the power is also increased as well. So under this logic, we are doing some estimated simulation. The ABC module, the yield rate compared with TOPCon is like 0.7% increase. So of course here we might have some pricing that I'm not really putting into the correct price. But because for each square meter our installed capacity is increased, then that means that for our mounting and the engineering cost will be relatively reduced, and also the cables that we're going to use, of course, is going to be reduced as well. So that is for the mountainous areas. And second, for fishing is also like 0.7% gap as well. And for the offshore, about 0.7% as well. For the CNI scenarios, so here we are using a specific project in Guangdong province as an example. In this project, we are giving about 25% off for the electricity price. So under such a circumstance, our entire return of investment is about 13% for TOPCon, and for ABC is about 13.78%. So from this figure of simulation study, you'll see that the ABC yield rate is still relatively high than that of TOPCon. So what I want to say is that we have countered a lot of problems and difficulties, of course, but in summary, we know that right now the land cost is growing more and more, and we as the Design Institute, we are faced with a lot of difficulties, of course. For example, I've got a project that I've done for 2 years, and the rental is increasing from 1,500 to even 2,000. And because of this land cost increase, some of the projects cannot be completed as soon as possible. And especially for the areas where we have large electricity consumption, that is where we have the higher land cost. So that is creating a huge, even bigger cost for the engineering as well. And apart from land cost, also we need to consider boss cost and also the shading, etc. And I've calculated the economical analysis that I've just shared, but I did not really consider the accumulated yield that can be generated when shading is happening. So overall speaking, my understanding is that for ABC module, in terms of technological innovation and its design logic, it actually helps us to solve a lot of existing problems that we are having difficulty in solving, especially when we are doing some of the projects and when we need to select certain modules that we're stuck in the middle. For example, some of the CNI scenarios that one factory, that the surrounding factories are generating a lot of things that is directly laying on top of the rooftop, for example, bird droppings, etc. That's the hurdle, the difficulty that we're faced in the existing projects. So those are the content of my presentation, starting from the very first part about the development trend and the policy. I would say that right now, the PV development that we have is far from enough. We still have a long way to go to move forward. That we are approaching 2024. In the coming 6 years, we still need to have a lot of strong installed capacity, and we are going to be facing more and more challenges and difficulties. And still touching upon the policy from the national policy side and the electricity exchange market. Right now, we are actively reducing the contribution from the coal consumption, and that's why we are having more space and room for the consumption of renewable energy. So, based on those policies that we have, I think that we can all together solve the problems that we have in the PV industry and move forward. Thank you all. Thank you for your presentation, for a detailed and insightful speech.
We would also like to thank Mr. Zhang to share with us his high appreciation of the AIKO product. And now let's give the floor to the next speaker, the head of the PV Technology Department of Huanan Clean Energy Research Institute, Zhao Dongmi, who is going to share with us about technology studies in the face of carbon neutrality. First, thank you very much for AIKO to share with us this platform so that we can share with all the experts and the guests about the ideas about the advanced PV technology. So first, about the amount of the installed capacity of the PV with the goal of carbon neutrality. This is widely recognized by the industry already, so we can see the global warming is being accelerated. Our target is that the temperature rise can be controlled within 1.5 degrees Celsius. For carbon neutrality, it's relatively simple for us. That means that if there is a balance of the emission and absorption, that is the carbon neutrality. For China to realize the carbon neutrality, we need to solve the following problems, and it has the following significance. Number one is that we can get rid of the external reliance of the energies. So in the year 2022, the energy demand is about 5.4 billion tons coal equivalent. We should also promote a global industry restructuring and to promote the reallocation of the assets. So take Huanan as an example. Before the year 2018, our major asset is a thermal power plant, which has a very large share. And we also hope that through the climate diplomacy, we can improve our international say. And also to promote the industry technology upgrading. Previously, we have the construction of the larger scale thermal power plant and the hydropower plant. We can also create new types of the jobs and to promote the circular economy. This is the challenge of the carbon neutrality in China. So we still have a very short time, but very daunting task. We should have the different methods to realize this goal. So it's like if we take a look at the hydro or thermal power, the new energy installed capacity is far from enough. If we want to neutralize the carbon emission from the thermal power plant, we need 7 or 8 times of the new energy installed capacity to neutralize that. This is the pathway for China to realize the carbon neutrality. So first for China, in terms of carbon emission structure, half of them are generated from the power generation industry. 36% are from industry, and the rest are the construction and the transport industry. What we need to solve is about emission from the power generation, and which is mainly from the oil and the coal, and coal takes up a much bigger share among the primary energy mix. This is the share of the different types of the installed capacity in the year 2022. So basically, by the end of 2020, the generation capacity of China is less than 2.6 billion kilowatt hours. And according to this prediction, and the prediction in 2025 and 2026, the PV installed capacity can be more than 80% among all the renewable energy installed capacity. So this is information of the global, not just about China, but according to the prediction in the year 2060, the installed capacity for the coal-fired plant should be restrained within 50 million kilowatts, and for natural gas is about 30 million kilowatts, and also 20 million kilowatts from biomass power generation. There will be a new development stage for nuclear power generation, which is about 30 million kilowatts, and 70 million kilowatts of the hydropower, and the new energy, which is about 480,000 kilowatts from the new energy. So PV power generation will be more than 60% of the installed capacity of the renewable energy. So how can we realize the reduction of the carbon emission? So for the thermal power plants, there were two ways. So number one is to reduce the utilization hours. So that means that renewable energy is to support demand of the power. And second one is to increase the installed scale. In the North China, in the winter time, the heating is needed, which is provided by the thermal power plant. If we can renovate these capacities, and then we can greatly reduce the carbon emission intensity. We have three types of the solutions for carbon neutrality. Number one is to change the energy mix, and currently we can use this centralized and distributed power generation at the same time. And for the distributed power generation, we'll focus more about these household utilization. And also we should focus on the core technology development, mainly the low carbon technology, which is about the new energy, and the negative carbon technology and the carbon capture. We should also get full play of the market to have the carbon trading market. There were 6 key technologies. Number one is the wind power, including wind resource evaluation and the building of the offshore wind power. In terms of the power plant, there are the core technologies, including high-temperature gas-cooled reactor, and the core technologies maintenance and operation of the pressured water reaction nuclear power. For clean coal and the CCUS, we should use the technology to reduce the carbon emission. In terms of the hydropower, we should further develop more hydropower. Number 5 are the new technologies, including energy storage and hydropower. The last one is the core technology, which is the solar power. We should work on the development of the new generation of the high-efficient batteries. We should also have the smart technology application. In the 14th five-year period, we predict that the new energy installed capacity will be about 80 gigawatts, and PV will take the largest share. And in the 14th five-year period, we have increased by 45 gigawatts of the newly installed capacity for PV. In the year 2025, which is the end of the 14th five-year period, the installed capacity will be more than 50 gigawatts. For PV. Currently, PV are mainly focused on 2 directions. Number 1 is about the building of the large base, and now Huaneng is working to build the projects in Inner Mongolia and Xinjiang about integration base of the thermal power plant and the PV. Solar power and wind power. We're also accelerating the building in Xinjiang and other areas about major base of the storage of the energy through the water and the PV. And now, these new bases, the installed capacity of the PV is mainly about 5 gigawatts, and some are even more than 10 to 20 gigawatts of PV. In terms of the distributed and some PV and storage and the solar power integrated bases at the centralized shores are also the area we are working on, and their installed capacity will be about 10 gigawatts. About PV technology has been shared by many different speakers already. I will not go into detail. For this ABC technology, efficiency is much higher than the traditional ones, and the industrial chain is developing, and we can see the increasing demand for the N-type of the cells. In the year 2025, for the N-type modules in our purchasing structures, that will be about 80% of the Huaneng Group, and that will be a major or mainstream product we are about to develop in the future. According to the prediction, in the year 2030, we can see there will be 60, in the year 2023, the BC cell capacity and plan will be increased to 64 gigawatts. BC has another very core technology advantage, that is the higher efficiency. Indeed, the utilization of the land is very challenging. So with the same area, we hope there will be highly efficient modules, and all of the investment and the return on investment can meet the economical operation of the company and of the demand of the industry. PV technology of Huaneng Group, we are developing this perovskite PV technology, and the certification efficiency is about 18.5%. Later, we are also working on the R&D of the perovskite stack technology. So we started from the small area to the micro performance module to the matrix stacks and the full application. This is a systematic study. In terms of the highly efficient PV modules, we are mainly working for the tracking. We hope that we can have an in-depth knowledge of the PV technology development and the product progress. So in terms of the flexible PV support in Yunnan, we are also having this volume production. Last part is about, in terms of digitalization, Huaneng is also working, doing very well and taking the lead in the industry. We have this 3D design and visualized infrastructure construction. We also have a PV station monitoring system and malfunction diagnostic technologies. Now, for this smarter technology, in this year, the installed capacity is about 30 gigawatts. That is for all the regional companies, we can have all the interface of these local branches, so that we can have a full statistic analysis. In terms of constructions, we are working together with the other partners to set up these base energy bases at the desert and the Gobi and the room temperature, etc. We are working together with Pakistan to set up a outdoor certification construction. So we hope that the product at different scenarios performance can be evaluated, and we can further promote these different types of the technology. We are also working together with AIKO, and we are also setting up the PV station for this Jiayuguan Gobi Desert by Huaneng. In the future, we are going to further working on the different areas like the desert and the mountain areas and high temperature areas. We are having very intense cooperation with AIKO. This is the plan. We hope that by having these empirical studies on different application scenarios, we can build these typical scenarios base to build the full database for different scenarios and work as the basis for the selection of the models of the equipment when building the PVs. And we can use the different PV modules at the different locations to prevent that all the scenarios will use the same type of the PV product. For example, we all use the TOPCon or we all use the PERC for different scenarios. We hope that by differentiating modules for the different scenarios, we can also improve the design. So these are the work done by Huaneng. Thank you very much. Thank you very much for the sharing. And please take our seat. So, with the preference of the technology and the quality at the beginning, AIKO ABC has been very well paid attention to by the international authoritative organizations. So today we also have the Dr. Crystal Monocrufso, who is the head of the global head for the solar business of R&D Technology Competence Center of TUV Rhineland, to give the certificate of the new product.
Solar Business and R&D Technology Competence Center of TUV Rhineland. Dr. Crystal Monokrosov. Welcome, sir. 同时也让我们用掌声有请
At the same time, we'd like to invite Mr. Sheng Jian, the Deputy General Manager from Product Technology Department, to receive this certification. We'd like to invite you to stand in the center of the stage.
Thank you so much. 欢迎2位。首先，我们将有请
First, we'd like to
为爱旭颁发
present Ryan TUV to issue and present the TUV certificate.
Please present the certification to AIKO.
Let's give a warm applause to the 2 guests online.
Photographer to first this honorable moment of AIKO. Thank you so much. 谢谢，我们再次把掌声送给。
Now let's give a warm applause to AIKO. Congratulations.
谢谢。
Thank you.
And gentlemen, please stand still on the stage. 接下来我们将颁发另外一个证书。我们先
Now we are about to present another certificate. Please help to take this certificate.
请申总留步。接下来我们将继续有请 Dr. Crystal 来为爱旭颁发
Now Dr. Crystal is going to present the TUV MCS certificate to Mr. Sheng. Congratulations. And now please look at the photographer and let's give a warm applause to congratulate this memorable moment, which is a very beautiful moment for AIKO. Congratulations again. Thank you.
Thank you, gentlemen. Thank you so much. Congratulations. Please take a break. Thank you. Thank you. 谢谢，我们也再一次感谢 Crystal.
We'd like to thank Dr. Crystal again, and we would also like to thank Mr. Sheng to witness this glorious moment and historical moment for AIKO. And we would also like to thank you for the witness of this important moment. As human civilization continues to evolve, the zero-carbon energy revolution and transformation are imperative. AIKO will always pursue cutting-edge technology, continuously redefine the PV and reconstruct the efficiency of photovoltaic conversion. I believe that the development of every step of the AIKO cannot be realized without the trust and support of every partner. So in the future, we hope that we can make sure the future will become reality. Let's jointly ignite the fire of science and technology innovation and jointly embark into the era of the zero carbon energy to contribute to the sustainable development of the planet. And distinguished officials and guests, the 2023 the ABC Bi-Facial Module launch ceremony with the theme of innovation beyond imagination concludes now. We'd like to thank you, all of you, to take the time to be here, and we also hope that in the future we can meet you together in AIKO. Now I'd like to invite all the guests to move to the resting area outside. We are going to have the rearrangement of the site. Please be here at 1.5 hours to enjoy the banquet. Look forward to meet you later. I would also like to remind you to leave your headset on your seat. Thank you very much. See you tonight.
Wir sind hier in einem schönen Einfamilienhaus in Wuppertal. Es ist ein Szenario, das wir vermehrt sehen. Familien fragen immer öfter nach hochwertigen Solarlösungen für Eigenheime. Der Umweltgedanke spielt in der Gesellschaft eine immer größere Rolle. Und man ist mit einer eigenen Stromversorgung einfach für die Zukunft gut ausgerüstet. Bei Aufdachanlagen zählt vor allem die Leistung, weil die Dachfläche limitiert ist. Wir empfehlen die Hochleistungsmodule von AIKO. Die ABC-Reihe hat den höchsten Wirkungsgrad auf den gesamten Markt. Besser geht's nicht. Das ist sehr hilfreich, wenn man eine Komplettlösung von einem Hersteller bekommt, wie das bei AIKO der Fall ist. Das ist vor allem für Eigenheimkunden wichtig.
Wir als Winzer, wir arbeiten natürlich hier mit der Natur, wir leben von der Natur und deswegen war es für uns ungemein wichtig, dass wir hier ein schlüssiges Konzept für unseren Bau finden, wie wir maximal nachhaltig unsere Energiebeschaffung organisieren können, auch aufgrund der Lage, weil wir ja im Außenbereich sind, mitten in den Weinbergen. In Zukunft